Hello YouTube, RJ. Hey, I'm up to stuff again today. I'm making some mods in the lab and we're going to have to make some parts. Probably going to have to do a little 3D CADing, do a little bit of 3D printing, a little bit of Ingenuity, and hopefully improve the camera setup on the bench. You know, maybe I won't get my hair in every shot and maybe the color and image will be a little better on the bench on my downward shot and stuff. So I've got some crazy stuff going on. Spend a little money. Gonna try to improve the videos a little bit for you. Give me just a second. We'll swing around and I'll show you what I'm up to. Okay, we're on the bench and here's what's going on. I have been putting my Pocket 3 Osmo that we're filming on right now up and just basically setting it up here on the spectrum analyzer to get the shot forward. And I've come to find that I like that shot forward. I think most of my viewers do. You seem to respond well to it. So I've decided that I'd like to incorporate that as a standard shot in my videos on the bench. And I really need to keep my Osmo handheld free and not be dealing with it up there. There's a couple problems using it up there. One is it's hard to get it stable where it won't fall over and get a good shot. The other problem with it is that it's battery, so I have to be careful that I don't forget, leave it on, run it down. The other thing I like to do is forget to turn on record with it too. Sometimes you can look back at a couple of videos where I was doing a lot of forward shots and all of a sudden they went away, and the reason was I forgot to turn this camera on. The rest of my cameras are all automatically. When I start recording, everything comes on. Everything's automatically synced, so it makes life very easy. So what I've done is I've broke down and bought a couple more cameras. And so the cameras I've bought are the 4K Pro webcams. Give me a really nice video. For the money, you pretty well can't beat them. And so what I've done is I'm turning, if you can see here, I've got one of them hooked to one of these mounts. Here, let me hold it up a second, that I purchased. And what I'm doing is I'm going to mount this up on the wall up here where I've got a permanent camera with the view that I want. And the problem I'm going to have with this mount is because the cable sticks out, the USB cable sticks out far enough that I'm very close. I can get it against the wall, but can't turn the camera freely to where I might want it. Here's what I've got in mind for the first step in this project and getting that camera mounted where I want it is to take, this is an exact copy of that. You're going to see where this one's going to be used, but it's going to screw in the wall with 3 screws, as you can probably make out. What I thought I could do is 3D print a ring spacer, just give me some thickness here for the screws to go through to bring this out from the wall and give me some room to clear that plug where I can move that camera around as I wish. So that's going to be the first thing, is to jump on Rhino 3D CAD and create a spacer for this. So that's the first part of our project. But let me tell you about what else. I don't want you to think that's all there is to it and have you run off and leave me. So let me tell you what else we're going to do. I've got a crazy idea. Let's look at my overhead cam. Let's back up here a minute and take a look. It's clamped on one of these gooseneck units, as you can see, and I bring it down. It's a little zoom capable webcam. Mechanical focus, mechanical zoom. Has a very narrow focus range, and you guys have caught me where we're working on the bench sometimes and things will get out of focus on me. And it can be so sensitive. To give you an idea of why that's so easy to happen is if I have a circuit board laying flat here on the bench and I focus very well on that circuit board, in a lot of cases the very top of this right here with that little bit of height will be out of focus. That's how narrow the focus range can be. Because of that, I don't want to autofocus up here, because when I put autofocus up here, move my hands around, everything focuses, unfocuses constantly. This camera also doesn't, as I'm sure you realize if you're a viewer of mine, doesn't have the best color, and sometimes it's a little muddy. Things aren't really crisp and clear. I had this idea. I have that problem, plus by the time I get this set up, when I'm soldering, I bend into solder on the bench here, okay? I gotta worry about bumping this or getting my hair, my head sometimes. Sometimes I go back and start working on editing videos and find out I keep leaning into the camera where you see the hair on the top of my head. So that's a problem. So I'd like to be a little better set up than that. So here's what I've got. I want to get rid of this whole gooseneck thing, make it go away. Just take it off. I'm going to take another one of these 4Ks right here. And this is the first one I bought to try this. And I went ahead and I temporarily mounted it right here looking down on the bench. And that has a wider angle. It's higher resolution. Gives a much clearer, much better view of the bench. And of course the first thought, let me flip around here a second. So the first thought is, of course, as soon as I do this, what's going to happen? Well, I'm going to lose zoom. You're not going to be able to zoom into a board and such. But here's the thing, when that camera is in that position, the distance is short enough that I can focus, that whole area stays in focus. I can lock it not to be autofocus and I get a beautiful shot. I've tested this already. But because it's 4K instead of high definition, I've got additional resolution, and what that allows me to do is zoom digitally in my editing software. So I can just film, don't worry about it, and when I'm done and we're working and I have an area I want to show you, I can digitally zoom in, keep high definition, don't lose any resolution, zoom in and show you that area. And it works quite well, the tests that I've done. So I think this is going to be a big improvement. But first, we've got to overcome some challenges, and that is how do we mount that camera and make it productive. So let's flip back around and talk a second. I want to mount this to the shelf, but what I'd like to be able to do is reach up here and bring it down closer if I need to. I'd like to be able to move it, okay? I'd like to be able to swing it. There's times I like to be able to focus on the spectrum analyzer and get video directly of that, sometimes of the scope, sometimes of the meter. So I had this crazy idea that if I took another one of these and I mounted it all the way to the back here, and let me see if I can do all this one-handed without making it look horrible. Get this camera pointed down for me some. Okay, what if I was to take a piece of arrow tube left over from our Yagi fox hunting antenna, okay? What if I could take this? This stuff's hard one-handed, so you'll have to bear with me. But what if I was to put that on there, which fits quite nicely, has just a barely little bit of slack in it. What if I was to take a little JB Weld, clean this, sand this up, clean it up, and JB Weld that and make me a long adjustable tube. Cut it off somewhere around here. And then take another one of these tubes, cut it off, and parallel it like this. Then what I would do is this one, I would attach one of these adjustable ball joints to the end like this. Hopefully you can think about where I'm going here. The camera can mount there. This, I can 3D print some clamps here and here that holds these parallels that lets me clamp them tight, loosen them, and slide this in and out. Now I've got something I can put up here like this, set up to where it shows the camera normally, but I can tilt the camera down. Let me loosen this a little. I can tilt this camera down with this. I can loosen the clamp on this and telescope this in and out. And this ball joint on that end will allow me to move the camera in two-dimensional space. I now have something I can leave here, up here on the top of the shelf where I won't get my head in, I won't hit it, that I can bring down to the bench real close if I need to. I can pull it down, telescope it out, swing it over here, and look at the screen here. I can do whatever I want on this bench. It's just as flexible as this thing, but more usable. So that's my idea. That's what I want to do. So I don't know if we can do it, but we're going to try. Let me get on the computer, jump in the 3D software. Let's start trying to design the spacer for this first camera and see how far we get with this. Now, I don't know if this is going to be one video or two videos. Depends on how much content I generate, how much I feel I can cut out without taking too much out. You know, I don't want to make the videos too long for you guys and bore you, but at the same time, I don't want to take out parts that you might really want to know how I did or be interested in. So it's a challenge. It's a balance. It's always a balance. Okay, so let's talk about how we get started. So the first thing I do in a project like this is I've got to get some dimensions. So I've already decided that I want about 20 millimeter thickness in that spacer. I want to hold this rascal out from the wall additional 20 millimeters. That'll give me enough room to swing that connector with the wire behind the wall. I believe I'm going to be good there. So I went ahead and I've drawn on a sketch pad, because I start out hand paper everything, 20 millimeter in a circle. And now what I'm going to do is I'm going to grab my micrometer and I'm going to mic out the diameter of this disc. And none of this is super exciting, but you know, I want you to see the whole process so you fully understand what we're doing. If there's something you're not interested in, just jump ahead. I don't see the extra information hurting anybody. So I'm micing that out at about 69.95 millimeters. That's so close to 70 millimeters. I'm going to call it 70 millimeters. So let's plan on a disc with a diameter of 70 millimeters. So I'm writing that down on my pad, my little diagram here to show me. Now, what else do I need from this spacer? I've got to have some holes here. And these holes are going to need to be, let's make them a little bigger than the holes for the screws to make our life. About 7 millimeters will do it. So let's plan on 3 7-millimeter holes. Okay. I'm drawing it on my plans. We've got to be 3 of them. 3 of them are, of course, going to be 120 degrees apart, right? But we need to know, and this chair is going to squeak during this. I'm sorry. I'll apologize now. There's not much I can do about it. Those holes are going to need to be about 8.75 millimeters in from the edge. Okay. Now, with that information, I think I've got everything I need to build this. So let's go over to the computer. Let's get Rhino 3D fired up. Let's go in and start we'll call that a small object in millimeters. And we'll go ahead to the top view. What I did there was you've got your top, front, right, and your perspective. And at the moment, I just need the top view. So I'm going to maximize it out. Here's our origin, which we can build this anywhere we want. So what I'm going to do is I'm going to start out by making a cylinder. And I'm going to go ahead and start it at 0.000 in the CAD program. And we need to know what the radius is going to be. And we set our radius, well, let's go to diameter so we don't get confused here. D changes me to diameter. And I'm going to tell this thing I've got a 70 millimeter diameter. Okay. Bam. Let me zoom out. Okay. End of cylinder. It wants to know how high the cylinder needs to be. And it's going to need to be 20 millimeters. Okay. So boom. So let's take a look at what we've done. Go to perspectives. I'm going to go ahead and tell it to fill it in or render it to a shaded. Okay, that's what we created. This is going to be our spacer. Okay, so let's go back. Top view. Now that's our spacer. Now the only thing we really need to do to this spacer is put some holes, but we need to be pretty precise at where we put the holes. This is where it's going to be a little bit of a challenge for figuring out how to space it 120 accurately, but I'll figure it out. You might have to bear with me. If I pause the video and jump back in, it's because I didn't want to waste your time as I figured this out. I've done a lot of things on this CAD program, and I'm trying to remember how I've done that before when I've needed to do this thing. But here's how I make holes in objects. Rhino makes it very easy because what I can do is do what I just did. I can make a cylinder, okay? I can go ahead and make that cylinder at location 0, 0, 0, okay? 3 coordinates where I'm putting it, boom. And I can tell it I want a diameter. What did we write down here? We wanted 7 millimeters roughly. So there's my 7 millimeters. And then end of cylinder, again, how long that cylinder is going to be. Well, guess what? We're going to make it really long. This thing's 20 millimeters. We're going to make it 50 millimeters. Why? I'm going to show you. Because when I pop back out and I go to a front view, I can highlight that new cylinder and drop it below the cylinder. Now it sticks through that cylinder. And here's what's neat about Rhino. I can take this cylinder, slide it straight up to where I want it to be, and I can have it remove that and make a hole there that size very easily. So here's what we've got to do. We want to come away from the edge by 8.75 fairly precisely. So let me get a dimension. We want to dimension this direction. Let's start right at the edge. If you look at the bottom of my screen, right here, it's showing me how many millimeters I've moved that. So I'm going to come out 8.75. 87. Zoom in to make it very accurate. Almost there. 8755, 8752, too far. 495, right there. Now, let me draw this dimension out, highlight it, and slide it over. And what that will do for me is it's going to give me a point to shoot the center of this object. So if I bring that line and join those lines together, I'm going to go ahead and zoom in. If I bring these lines perfectly together, I'll zoom way in to make it very accurate. That should be accurate enough. I now have that hole 8.75 from the perimeter. So we're good. So now I can get rid of that dimension. I've now got my hole, my first hole at the very top, right where I want it. Now, how are we going to do this again? Well, I'm going to take and highlight that. And I'm going to go ahead and copy it. Okay, here's what I'm going to do. I'm going to measure from the center out and get a dimension. 26.3. Here's what I'm going to do. 26.3. I'm going to go in. I'm going to make a cylinder from the center point. And I'm going to make it the radius of it. Change the radius. I'm going to make it 26.3 millimeters. Now that should pass through the middle of our circles. So that'll kind of get us underway. Now we know where the center of this circle needs to be equidistant. Now let's rotate 2D. I've got center on, so I can just go to the circle. It'll plot me at the center. And then I can tell the next angle will be 120. Okay. Bam, I got one. Now let's go in and make a copy again, edit, copy, edit, paste. Okay. Let's rotate this one 2D. Center rotation is going to be the same center. And we're going to be 120, 120 is 240, right? Bam, there you go. That works. I can get rid of this circle. Let's go take a look at what that looks like. Here's what it looks like. Turn that off, do solid. I'm going to do, I want the difference. Keep this one, enter, and then highlight these. And when I hit enter, it's taken those cylinders away and left me with perfect holes, 120 degrees, right where I want them. Now, that wasn't too bad, was it? It took me a minute to figure it out, but it's really pretty easy to work with. I find it to be a great piece of software. We've got what we want. This is basically all we have to do. What I can do is do file save. Let's put it in my 3D print stuff. Let's put it under a new folder. We'll call the new folder cam mounts. Okay. And we'll call it wall mount spacer. Okay. Now it's saved as a 3D Rhino file, but that's not what my 3D printer is going to use. So I have to save this. I have to save as again, and this time I'm going to tell it to make it stereolithography, STL file. Same name, same place. It's going to ask me what tolerances I'm looking for. It's going to ask me some options. The defaults that I've set up work very well. And so with that, we're done. We're all done. We can close Rhino. Okay, well, right after I got done and closed this out and was going to go load it up on 3D printer, I realized I was being really dumb. If you look at this is all open in here. The only thing that really hits the wall is this ring here and these spots where the screws go in. Why do I need to have all that material wasted in here for my spacer? It seems kind of stupid. So when I realized that, I decided I want to jump back in here and wanted to go ahead and make some changes. And so when I got done printing, it was going to be very different looking than what I created. So I didn't want you confused. I want to show you why and what I was doing. So here's what I'm going to do. I'm going to go in here, make another cylinder centered in my product like this. And I'm going to bring it out. I'm going to turn center off so it doesn't keep jumping me where I don't want to be. I'm going to make a cylinder about that big. I'm going to make it this tall, and I'm going to slide it down through, and I'm going to take it right out of that. Same way we did before. Solid, difference, click on the one you want to keep and enter. Click on the one you want it to cut out, enter. And now we get this. Now look how much less material I'm going to have to print. And I'm going to have solid walls going down in here, which is going to make it kind of stiff there anywhere where I want it. And there's more we could do. What if we went in and took some more out here? Do we really need all this? Probably not. We could probably do some additional stuff like, oh, I don't know. What if I took and drew a good size square like this, made it nice and long, dropped it down in there, told it to rotate in the center like this. Let me turn off ortho. Turn it like this, slide it up in like this. I could then copy that, put him over here, rotate him. You see where I'm going. I could take a lot of extra material out. And it wouldn't hurt a blooming thing. This thing's going to be no weaker for it. Let's bring this one in a little, leave a little extra out there. So if I was to do this and go solid, difference, leave this, enter, and then choose all of these and enter, look what I would end up with. Now I'm going to speed up less material, less waste, a lot faster printing, right? Probably going to print that a lot quicker. So let's find out. Let's see what happens. And now when I bail out of this, let's go take a look at it now. This is in 3D printing where you can make enormous differences in time, speeding, if you really think about your projects. So let's go file, open a file. Let's open number 2. Look at that, looks a little different, doesn't it? Let's leave it on those settings. And let's see what we come up with. 1 hour and 47 minutes. Really didn't save me as much time as I was hoping it would. Interesting. A lot less material. 27G. We're using, geez, it's almost half. A little bit more than half. Yep. So let's save that. Overwrite that one. Yes. And now I'm ready to go throw it on the 3D printer. Okay, let's talk about how we ended up. Okay, here's our spacer. I'll let you see. It turned out just the way we designed it. See the screws go right through, lines up perfect. Doesn't look bad. It's going to go on the wall. It's going to work great. So I'm going to go over and get this mounted on the wall. Okay, and after a little bit of drilling and putting some drywall inserts in, found a couple black screws that fit good. We have our camera mounted. Let me get in here and kind of go around, let you see. Doesn't look too bad. I don't think it looks bad at all. From now on, when you're seeing that frontal view where you see me on the bench talking to you. Back up a little bit more here. That's where you're going to be getting your view from. That should work out very, very well. Should give us a good view. And I'll be starting to work on our new mount for the other camera. I've got the other camera just sitting right over here at the moment on top of the power supply. And I'm going to be starting on this. This may be the end of the video. If it is, hey, thanks for watching. Sorry I couldn't get far enough into this. I just didn't want to turn the video into a real long video. So I will kick over and start another video. And we will take off building the mount for that camera. So I hope this is something entertaining and educational for you. See how I do these projects and how I take things like CAD and 3D printers and put them together to get things that I want the way that I want. I really enjoy making stuff. Even when I can buy something that might work for me, just the joy of building your own unique item can be well worth it.